Hello, my name is Keshwani. That's Keshwani, Keshwani. I have been solving math problem for GMAT out of this book here, the GMAT review, the official guide. If you do not own this book already, purchase one immediately. You will find it at mba.com. The problem that I'm about to solve is the one that you will find on page number 172, problem solving 148. Let's take a look. It says, what is the lowest integer that is the sum of three different primes, each greater than 20? Each greater than 20. The only thing that I can think of that might throw somebody off is not knowing what they mean by prime. By primes, they mean prime numbers. What's a prime number? Prime number. This is their favorite topic. Quite a few problems appear dealing with prime numbers. A prime number is a number that goes only in itself and 1. That's it. A prime number does not go into any other number. For example, 25 is not a prime number because 25, in addition to every number will divide by itself and every number will divide into 1. You can take any number and divide it by 1, and you can take any number and divide it by itself, you get 1 for the answer. Question is, if that is all that you can do with the number, if the number does not go into anything except itself and 1, then it's a prime number. 25 is not a prime number because 25 will go into 5. 32 is not a prime number because 32 will go into 2, 32 will go into 4, 32 will go into 8, it will go into 16, it will go into many numbers. 32 is not a prime number. Of course, even number cannot be a prime number. I'm going to quickly give you a list of some of the prime numbers. And since they are looking for what is the lowest integer, that is integers on, if you don't know the terminology again, these are some things that you should know for GMAT if you're going to sit for it. Even if you have not dealt with these terms for 20, 30 years in your career, for the exam you have to know them. Integer is just a fancy way of saying a whole number. An integer is just a whole number. What is the lowest integer? That is the sum of three different primes, each greater than 20. It would have been nice if they had said, what's the sum of three different prime numbers greater than 20, each greater than 20. But they don't say prime numbers, they just say primes. Why? Because they like to be cute. So I'm going to make a list of primes or prime numbers. And I'm going to go all the way. We'll see how far we can go. So let's start. 3 is a prime number. 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, 25, 27, 29, 31, 33, 35, 37, 39. Let's stop there. Are these all prime numbers? Well, we'll find out. 3 is a prime number because the only number that you can divide 3 into is itself and 1. 5 is a prime number. 7 is. 9 is not because 9 goes into 3. 11 is a prime number, so is 13. 15 is not because 15 will go into 3 and 5. 17 is a prime number. 19 is a prime number. 21 is not. It will go into 3 or a 7. 23 is a prime number. 25 does not qualify. Neither does 27 because you can divide 27 into 3 or a 9. 29 is a prime number. 31 works. 33 does not. 35 does not. 37 works. 39 does not. Because 39 will go into 3 or 13. So here is a list of your prime numbers and so on and so forth. The question is, I left out one prime number on purpose. What is one prime number that I leave out? That I left out? The answer is 2. 2 is the only even number that is a prime number. Why is 2 a prime number even though it's an even number? Because it meets the condition, it meets the qualification, which is only number that 2 will go into is itself and 1. And because 2 meets the requirements that it only goes into itself and 1, therefore, even though it's an even number, it qualifies to be a prime number. 2 is the only even number. No other even number will be a prime number, because if it's even number, by definition, it will go into 2. Any even number will go into 2, and that's the end of the story. Because if it goes into any other number other than itself and 1, it cannot be a prime number. All of this is not required for this particular problem. I'm just doing some extra work here. Let me take a look at the camera here. Sometimes I have a tendency of doing too much of a pep talk. Let's see what happens. I think I better wrap it up because I'm already over 5 minutes into it. So, we're looking for the 3 different prime numbers. They have to be different. We're looking for 3 different prime numbers, each greater than 20. So it's very simple. Here's one. This is more than 20. Here's another one. That's more than 20. So I got 23. I got 29. And here's another one. That's all. I find the sum of these 3 numbers, and that's all it is. We're done. Right here. So that's what I'm going to do. 23, 29, and 31. 10, 13, carry 1. 6 and 6, 3 and 3, 6 and 83. That's your answer. The answer is 83, which happens to be letter E. You see, it's tricky because they're looking for what is the lowest integer that is the sum of 3 different prime numbers. It turns out that the correct answer, in fact, is the highest in the answer choice, 83. All the other answer choices that you see there, these are for people who are not paying attention, and they're picking numbers which are not prime numbers and adding them up. You know, maybe they're looking for more than 20, maybe they're adding up these numbers, 21, 23, and 25. What would that give you? 8, 9, that would give you 79, or 69, right there. The very first answer choice is the sum of 21, 23, and 25. But they're not prime numbers. 25 is not a prime number, neither is 21. Anyway, the answer is E. I hope you found this helpful. If you wish to buy my videos in which I present to you the solutions to all the math problems for the GMAT in this book, there are about 400 of them, 250 problem solving questions and about 150 data sufficiency questions. If you wish to acquire those DVDs, or if you wish to hire me for personal private tutoring, I'm located in Connecticut, but of course I'm willing to come anywhere as long as it's worth my time. In either case, send me an email. Go to my website at www.prep.gmat.com. Send me an email and we'll talk. Alright? Thank you.